Okay, year 11th, here is going to be a recap about what we have done in the lesson. So how to factorize a cubic function like this. So in the lesson, we first focus on this constant value and find about the factors of that. So the possible factors in this case will be plus or minus 1, plus minus 2, plus minus 3, and plus minus 6. And what we'll do next is to substitute all these values into our polynomial function and to see which one will give you the answer 0 and then apply the factor theorem. Okay, so let's try p negative 1. And then you're probably going to notice that it's not equal to 0. However, if you do with p1, this will give you 1 minus 2 minus 5 plus 6, which is equal to 0. And this actually implies that the factor will be x minus 1. Okay? So x minus 1 is the factor of px. And because of it's a cubic function, we know it can be expressed as x minus 1 multiplied by another quadratic factor. So we're going to write as x squared plus bx plus c. Okay? So then if you expand that, you can use the knowledge of equating coefficient to find out the b and c values. So in the class, we did the method, which is long division. So you can also do that to find out this quadratic factor by doing that. Alright, so quickly do it. X minus 1. So x cubed divided by x, you have x squared. And then you multiply that, you get x cubed minus x squared. Then you do subtraction. Alright, so minus 2x squared. Now minus minus here will give you a plus. Therefore, it's going to be minus x squared minus 5x. You carry down this term to this line, all right? Then minus x squared divided by x, you have negative x. Then there will be negative x squared plus x. Again, you do the subtraction. This time it gives you negative 6x plus 6. Negative 6x divided by x, and the answer is negative 6. So again, you multiply that by x minus 1, you have this. Alright, and the difference in this case will be equal to 0. So it's a way for you to check whether x minus 1 is actually be the correct linear factor of your polynomial function. Okay, so the remainder must be 0. Okay. And then what we do further is now the px, the polynomial function, can be expressed as a product of a linear factor and a quadratic factor, which is x squared minus x minus 6. And for this trinomial, you've learned how to factorize it because it's a quadratic. So simply just write x minus 3x plus 2, and this can help you to fully factorize our cubic function like that. Okay, so there's going to be another method, it's called equating coefficients, which will be included in the next slide. However, if being provided with a cubic function like this, and then you think about, okay, so now the constant value is negative 3. And then try all the possible factors of that into substitution. But what you're going to realize is the a value can be plus or minus 1 or plus or minus 3. However, if you make the substitution, none of them will give you the answer 0. Okay, so that is the case when we have no solution as an integer for your polynomial function. And we will introduce the rational root theorem to you and to solve this case. However, if being provided with a cubic function like this, we're going to assume it has a linear factor ax plus b. A and b, both of them will be integers and relatively prime. A divides the coefficient of x cubed, which in this case will be 2. And b will divide the constant, which is equal to -3. So think about the possible values for a and b. A could be equal to plus or minus 2, b could be equal to plus or minus 1, or plus or minus 3. You may think about the case why a cannot be equal to negative or plus value of 1. And we will see that later. So now we want to find out is the value for negative b over a. So this will give you plus or minus a half or plus or minus 1.5. For the case about a to take the value of 1 or negative 1, we've already think about this in the previous slide. It's when the cubic function has an integer solution. However, in this case, it's neither the case. Therefore, you can only think about a to take the value plus or minus 2. Again, we'll try these values until we find the one allows p negative b over a is equal to 0 to find our first linear factor, which can be written as ax plus b. So we're gonna try with p of a half. Okay, and this will give you 2 times 1/8, and then minus a quarter, minus a half, minus 3, and which apparently that's not be equal to 0. Then you try the next one. So negative half, which will be 2 times negative 1/8 minus a quarter plus a half minus 3. Again, that is not equal to 0. And what I'm going to try next is going to be 1.5. And this will be equal to 2 times 27 over 8 minus 9 over 4, and then minus 1.5 minus 3. Okay, if you simplify that, you will see this is now equal to 0. And what that tells you is now the a value is equal to 2 and the b value is equal to -3. Okay, so always consider the case for a to take a positive value. And what that tells you is now the factors is actually 2x minus 3. Okay, then we can again find out the quadratic factor by doing either long division or equating coefficients. So let's do it with the equating coefficients. Now the px can be written as 2x minus 3 multiplied by x squared plus bx plus c, if you notice that. Because when we expand that, 2x times x squared should gives you 2x cubed. And the c value, you'll probably see that -3 times c will give you the constant, which is -3. Therefore, I can actually write x squared minus 1. Okay, so the c value will be equal to -1. So then you times, okay, so it should be plus 1. Okay, made an error here. So if it's 1, you multiply by -3, this will give you the constant -3. And how can we decide the middle term? We know the one containing x, so now in our original function, the coefficient of x is now equal to -1. If you look at this factorizing form and think about if we expand that, which terms will give you the x term, okay? This will be -3 times your bx, so that will be -3bx, and 2x times b, so which will give you 2cx. Because we already know the c value is equal to 1, so instead of writing 2cx, we can think about this as 2x. Okay? Now what you have to do is to equate the coefficients of -3b and to to match what we have in the original polynomial function, which is -1. So -3b plus 2 is now equal to -1, which tells you -3b is equal to -3, so b is equal to -1. Therefore, the factorized form for polynomial function px can be written as 2x minus 3 x squared plus minus 1x. Or if you want to simplify it, you can write 2x minus 3 x squared minus x plus 1. Okay, and then you can think about whether we can further factorize it. The rule for us to tell whether you can factorize it is to look at the value for its determinant, the discriminant. Okay, now in this case the discriminant is equal to b squared minus 4ac. Therefore, that is equal to 1 minus 4, less than 0. Okay, so what that tells you is there's going to be no solution for this quadratic equation and you can't further simplify it, factorize it. Okay, and that's why we're going to stop here. Therefore, the answer towards this question is px can be written as 2x minus 3 x squared minus x plus 1. Okay, so we're going to stop here. Okay, so now you can also try the same theorem based on this example. If you've been provided something like that, first thing you always look at is the constant value, and then see if you can find an integer solution for your cubic. Okay, because now the factors of -5 can be plus or minus 1, plus or minus 5. And then again, you make substitution into the polynomial function and to test whether any value will give you the answer 0. However, if you try with these 4 values, none of them will give you the answer 0. And therefore, we will apply the rational root theorem. Okay? So now we are to also look at the factors of your leading coefficient, which is 3. So it could be plus or minus 3. Alright, so now what we have to do is we're going to try other different new values into our polynomial function. So it will be the factors of your constant over the factors of the leading coefficient. Okay, so again we have some new options. So this can be 5 over 3 with plus or minus, or plus or minus 1 over 3. Okay, so again you're gonna try these values into your polynomial function. So let's try 5 on 3 first, and then you will have 3 times 5 on 3 cubed plus 8, 5 on 3 squared plus 2 times 5 on 3 minus 5, and apparently this one is going to be a positive value other than 0. However, if you try with p -3, 5, or 5 on 3, this should give you the answer 0. It may take a while to find out the answer, but don't worry about this. Okay, then this should be equal to 0. And what that implies is now the a value is equal to 3. Again, always think about the a value to take a positive 1, and then b is equal to -5. Therefore, 3x minus 5 is a factor of px. Okay? Then again, we can do equating coefficients to find out the quadratic factor. Alright? So now this case, px can be written as 3x minus 5 multiplied by x squared plus bx plus c. Because 3x times x squared will give you 3x cubed. Okay? And then again, consider what's going to be the value c can take, because now the constant is equal to -5. What that implies to you is -5 times c value will give you -5. So the only possible c value for c will be +1. Okay? And then think about the b values. The b value, you can again look at the coefficient of the x term. In this case, that will be 2. So to equate the coefficients, think about what you're going to have in the expanding form for our factorized thing. Okay? So there will be 3x times c, so it will be 3cx. And then minus 5 times bx, this will be minus 5bx. And these are the only terms you can get involving x term only. Okay? So what that tells you is these two, the coefficient of these two will be equal to the one we have in the original cubic function. So what that makes sense is 3c minus 5b is now equal to 2. And we know the c value already, which is equal to 1. So you can simply write 3c minus 5b, which is equal to 2, and therefore 5b is equal to -5, and b is equal to -1. Now you can complete this factor, which will be x squared minus x plus 1. And again, you can think about whether you can further factorize it. And because now in this case, the discriminant again is less than 0, which tells you can further factorize your cubic function. So you can leave your answer as px is equal to 3x minus 5, x squared minus x plus 1. Alright, so that to apply the rational root theorem, you always try to obtain a polynomial function like this, and then put that into a descending order with their powers. So you will notice that the highest power is going to be from n to n minus 1, n minus 2, and until 1, and power of 0, then etc. Okay, so now let's thinking about to find two values for a and b. And these two values are going to be integers and has the highest common factor of 1. So if ax plus b is a factor of this polynomial function, then a will actually become the factor of your leading coefficients. Okay? And then the b value will become the factors of the constant. And then what you have to do is again try to find out the possible values for negative b over a, and then substitute into a polynomial function and to see which one will actually give you the answer 0. Okay, and this will actually help you to find out the first linear factor, and you can either later use equating coefficients or long division to find out the quadratic ones. Of course, you can also use your CAS to help you to factorize any cubic function. So you can simply go for the action, transformation, factor, factor, and then type in the polynomial function, which you can have a try with this. You simply type in this function, okay, with closing bracket, and then press enter, and your CAS should give you an answer. And this will be something provided in your CAS. If you look at this, there's something you have to be aware. If you look at this quadratic factor, you should notice that it can be further factorized. You can either do this by hand or do it with the R factor in your CAS. Okay, so the R factor is just below in the table. Okay, if you choose that, this will give you the answer x minus root 5 plus minus 1 over 2 and x minus negative root 5 minus 1 over 2 and 3x plus 5. Okay, so if you use the R factor. Or you can do it by hand, because we can either do it by completing the square, or we can use the quadratic formula. So we can first find out the discriminant. So in this case, there will be 1 plus 4, which is equal to 5. Therefore, the two possible values for x will be negative 1 plus or minus root 5 over 2. And then you can actually write this will be x minus negative 1 plus root 5 over 2 and x minus negative 1 minus negative 5 on 2 as the linear factors of this quadratic one. If you see a cubic function like this, instead of doing like the division or try and error thing, it's easy for you to identify that one of the value for x to make the whole polynomial equation to be equal to 0 is going to be 2. So you can say P2 is equal to 2 cubed minus 8 is equal to 0. Okay, and then what you can do next, what this tells you is x minus 2 is going to be a factor. Then you can try equating the coefficient. So x minus 2, x squared plus bx plus c will be the factorizing form for the polynomial function. And then think about what's going to be the values for b and c. Negative 2 times c will give you the constant. Therefore, c will be equals to plus 4. Again, the value for b, you can find it out easily because here we have 0 x squared term and 0 x term. Okay, so you can use either one, doesn't really matter. So negative 2 times bx will give you negative 2bx, and x times c, which is cx, and we know that is equal to 4x, and the sum of this will be equal to 0 because we're going to equate the coefficients. What that tells you is 2b is equal to 4 and b is equal to 2. And therefore, the factorizing form of this cubic function will be x squared plus 2x plus 4 multiplied by x minus 2. And again, you have to check whether you can further factorize it. In this case, the discriminant value is less than 0, so you're going to stop on here. Okay? And now I'm going to rewrite this factorizing form to make it more sense to you for the future rule we are going to use. So it's going to be x minus 2, x squared plus 2 times x plus 2 squared. Okay? So you can notice that it's always 2, 2, 2 here. And that's going to be a shortcut for us to factorize cubic function if it's a sum of two cubes or a difference of two cubes. Okay, so if it is the difference of two cubes, we have x cubed minus a cubed. We can write this x minus a multiplied by x squared plus ax plus a squared. if it's px is equal to x cubed plus a cubed, and we can actually factorize it by doing x plus a, x squared minus ax plus a squared. Okay, we've done this already. And then for the sum, you can actually thinking about this as x cubed minus a cubed, and then do the substitution into this formula and you'll get this. So now with these cubic functions, it is easy for us to factorize it. So if you look at the first one, you will see 27 is 3 cubed. Therefore, it's a difference of 2 cubed value. So it's going to be x bracket x minus 3, x squared plus 9x, plus 3x plus 9. Okay? And then for the next one, don't forget when you factorize it, always take out the highest common factor. So this will be 8 x cubed plus 8. And again, you will see 8 as a cube value of 2. So this is going to be a sum of 2 cubed values. Therefore, if you want to factorize it, it's going to be 8 times x plus 2, x squared minus 2x plus 4. Okay? Now have a go with this question and then try to find out the values for a and b. And then think about what is the meaning if the polynomial function is divisible by x minus 2 and is divisible by x plus 3.